got the power. I've got the power in me. I've got the power. I've got the power in me.
Hey, hello, and welcome to the Protec Power Hour. Hey, we've got 5 days, 18 hours until the PowerTest 2023 conference down in Orlando, Florida. And today in the studio, we're going to be talking a little bit about the upcoming PowerTest, theme of some of the papers that are going to be presented there. And joining me in the studio, I'm quite privileged to have Jason Aaron, application engineer with Megger. Jason, you're going to PowerTest, correct?
Yes, Tom. First, thanks for having me. It's going to be about 4 days till we head to Orlando for PowerTest. Megger is going to have a best practices seminar before the conference. So if you're available, please join us for that. And then we have a paper that we're presenting on PD diagnosis of medium voltage cables and a cable testing seminar at the end of the conference. So a lot going on.
So they're actually going to make you work while you're there?
Unfortunately, yes.
Okay. Well, it's interesting. You said, you've got one of the track papers and one of the seminars at the end. I was just kind of looking through the agenda the other day, and the cable track really is hopping this year. I just kind of went through the library of everything that is going to be presented. We've got Corp with Ben Lance. You know Ben from the Insulated Conductor Committee.
Yes.
He's giving one of the track papers, Power Cable System Reliability and Longevity. Then big news, we've got Chasen Tedder is going to be talking in one of the track papers about the ANSI NETA maintenance testing standards updates as they apply to cables. So that's going to be a fantastic session to catch because there's been a lot of changes in the world of cable and cable testing and philosophy. Then the track paper that you were referring to, non-destructive partial discharge diagnosis of medium voltage power cables. Now your co-presenter, Joseph
Aguirre,
yes, is joining you on that one.
Yep.
Okay. And just looking at a little bit of the abstract and everything, I guess this is kind of a follow-on to what you guys had started. Was it up in Denver last year?
Yes, in Denver last year. So we presented a paper on partial discharge, and some of the feedback that we got back from that was that we kind of dove a little bit too deep into theory. And we had some people that just said, hey, look, we want to know a little bit more about how to do the testing. What do I do with the test data, the test results? So we wrote a paper kind of focused more on that, and we plan on talking a lot about that at the conference. This is partial discharge, and this is why we're doing it on our cables. This is how we apply it, and this is what we do with the data. So
fantastic. Well, honestly, I wish I would be able to attend that one, but I believe while you're doing that one, I'm on one of the track sessions. I'll be doing understanding tan delta testing. And it's interesting because I'm taking a very similar approach. Obviously, we'll cover theory, but I'm really trying to take more of a practical approach to the technician who is actually performing the test. What are some of the do's and don'ts and gotchas that, come up while, prepping the cable and setting up to be able to collect proper data, understanding that you're getting good data. We'll also talk a little bit about, the use of tan delta. There's a little bit of controversy in the technical community as far as its value as an acceptance test, versus maintenance test. So we'll be talking a lot about all of that. And then we actually have a really nice cable panel group this year that I'm quite honored to have been invited to join in on. So we'll have 2 sessions, again, just talking all things cable, and obviously, cable testing and diagnostics and everything are going to be highlighted in that. And then I think both of us have 4-hour seminars at the end.
Right.
I'll be covering partial discharge testing on medium voltage cable, but taking a look at both online methodology, pros and cons, offline methodology, pros and cons, and
Mhm.
talking again more of a practical approach of how we would approach it, and ultimately interpreting the data and making
Mhm.
sure that we're turning in good reports to our clients.
Right.
Now, yours is also test methods and data analysis for the medium voltage cables.
Right. So obviously, we have the paper to talk about partial discharge on medium voltage cables, but during the 4-hour seminar, we'll be able to expand on that and be able to talk about this is the approach for maintenance of your medium voltage cable. So we'll be able to talk more about VLF and and tan delta and partial discharge, and kind of how we use all of those techniques to be able to make the best decisions for
Beautiful. So
reliability.
I love that, because in mine, I'm going to be obviously focusing, as the title implies, much just onto the partial discharge aspect of it. But I love the fact that now you're addressing it where there are other diagnostic tests and everything out there, the tan delta. How does it all come together as a good comprehensive program for your
Sure.
cables? So
Mhm.
fantastic. Kudos to you. Again, wish I'd be able to sit in and I have to take a look at the time slots, because I think I'm at 8 o'clock in the morning.
Okay.
You might be the after lunch one.
I think we are. I'll have to double check that, but I believe so. Yeah.
All right. So you got to come to mine and keep me honest in what I'm saying, and I'll make sure that I stop in on yours then.
All right. Sounds good.
Fantastic. Well, it was interesting. Obviously, there is a lot of papers and discussions, everything that are going to be focusing on the medium voltage cables at this year's PowerTest. When I look at the theme,
Mhm.
we do see a lot of partial discharge being mentioned in there. And I was also looking back at the past, the winter and the spring NETA Worlds. And again, measuring partial discharge, medium voltage cable. Again, we're seeing this theme, coming up
Actually
over.
wrote that article.
That was yours.
Yes.
Okay. Well, when the camera's off, I'll get your autograph on it. Okay. I'll put that in my collector's bin. Someday it'll be worth a lot of money, I'm sure. But again, we're seeing this theme, partial discharge. And I am, again, looking forward to getting with the NETA community at PowerTest, particularly on the panel groups and in not so much in the papers, but between the papers during our socializing time.
Sure.
Because this is an area where there are a lot of mixed opinions out there, on the concepts of partial discharge.
Mhm.
Now, the one that I know you and I talk about a lot has to do with the controversy of, does it have to be power frequency 60 hertz as far as the voltage stimuli when using or doing partial discharge, or the alternatives to power frequency? We have the very low frequency VLFs, but even there, we have the 0.1 hertz sinusoidal wave.
Yes.
We have the 0.1 hertz cosine rectangular.
Yep.
And then the latest of the patch, what was it, IEEE 400.4, damped AC enters into the arena now as methodology.
Yeah.
And I know there's been a lot of discussion, a lot of controversy, particularly alternatives versus the 60 hertz. And a lot of it, correct me if I'm wrong, because you are a member and attend the insulated conductor committees and so forth. A lot of it circles around the partial discharge inception voltage testing.
Yes. Yes.
Where, if I understand correctly, it's not so much on the new and acceptance testing on a cable that might have a defect that produces partial discharge, had it never been energized before. The partial discharge inception voltage, whether it was taken at 60 hertz or whether it was taken at one of the 0.1 hertz derivatives,
Sure.
the PD/IV should correlate on a new cable that has not been energized. I'll just call it a virgin void that has not had partial discharge in it.
Yeah.
So again, if I understand this issue properly, it really centers more on the service age cable, where if there was a void defect in there and there had been partial discharge activity, it's going to leave semiconductive residues along the walls of the cavity.
Sure.
So at 0.1 hertz sinusoidal, the transition of polarity is very, very slow and elongated.
Right.
So my understanding is we lose correlation to the 60 hertz inception voltage results due to semiconductive residue on the walls of the cavity during the slow transitions, rather than allowing a charge to build within the void. We bleed a lot of the current through the higher dielectric loss of the semiconductive. And in essence, the partial discharge inception voltage under 0.1 hertz sinusoidal would trend higher than what it would actually have occurred at the 60 hertz.
Sure, it can.
So I believe that's the big controversy with the VLF world. But what a lot of people don't talk about, and I know, your company, really spearheads a lot of this technology. There is a very low frequency. I've always referred to it as the slope technique. You tend to use the term cosine rectangular, and I do believe that they're interchangeable.
Yes.
But can you elaborate a little bit on what is the significance of cosine rectangular, particularly addressing this partial discharge inception voltage issue on surface age?
Okay, so one thing that you mentioned, is that for partial discharge is that with sine wave, sinusoidal, 0.1 VLF technology, the time that it takes to go through one cycle is very slow, roughly 10 seconds. And the difference between, they still consider cosine rectangular to be very low frequency. However, the thing that's different is the transitions when the polarity reversal. So whenever you have the polarity reversal, the frequency is much quicker, and that has to do with the change in voltage with respect to
The
time.
switching matrix.
Right. So the DVDT, right? So during that transition, your frequency is actually closer to power frequency, but it's dependent upon the cable. So the characteristics of the cable are going to change the capacitance of the cable, and that's going to change the frequency that occurs during that transition. But the frequency that's experienced during that transition is closer to power frequency. So it's a test that mimics power frequency. And so there's a benefit there. Now, there are white papers that are written where there is frequency dependence of partial discharge. That's just the way that it is. However, the test results, there's similarities there. And as long as there's similarities, we can compare the technologies. And then there are benefits to being able to use cosine rectangular, or slope, if you want to call it that, technology for PD testing.
Very good. Now, the cosine rectangular, this is not some new emerging.
No, it's not. So cosine rectangular and damped AC have been being used for a long time for cable testing techniques. I believe, if I'm not mistaken, cosine rectangular was developed back in the 1980s. And so it's been around for a very long time. It's been being used over in Europe very effectively. There's a lot of white papers and case studies developed with this technology to show the usefulness of being able to use it for cable testing, and not only for medium voltage applications, but also for high voltage applications.
And that's very important to note, that a lot of what we look at here in the States and everything is we're being introduced to it Johnny come late in some situations. So we're looking at this as, wow, this is some new emerging technology. And wow, does it really have a track record? Does it really, live up to what the salesman is telling me? But the reality is 1980s, we were doing, well, I shouldn't say Europe was doing this cosine rectangular effectively. Now, I do know the damped AC, going back into my old age, I remember terminologies back in the day when it was being referred to as oscillating wave.
Right.
And if I'm not mistaken, those papers were again, 1980 vintage.
Sure.
I'm thinking. So again, this is another. Even though IEEE 400.4 was released in, do you remember the year?
I don't remember the
It
year.
was
off the top
within
of
the
my
last
head.
5 years, if I'm not
It
mistaken.
definitely is recent.
Yes.
And there's been recent changes to that standard as well. So it's still a developing standard. There's still criteria that's being developed, and that's just because even though it's not a new technology, it kind of is new. I shouldn't say new because it's been being used over in Europe. However, there's a lack of field data available. And
Right.
so there's some of the criteria that you use to judge the cable against that it's just not, there's not enough data available to be able to establish hard thresholds. So basically it comes down to the experience of the user to be able to make judgment calls on the data. But it's still, there's a lot of valuable information there that you can use to make judgment on the condition of the cable.
Okay. Now, we've got, let's focus in a little bit on the cosine rectangular in the VLF world. Okay, that is obviously a viable method. Good long history, white papers showing correlations and so forth.
Yeah,
we've got the DAC technology now, and I noticed and if you can maybe elaborate a little bit, but on some of the equipment that Megger is offering into the marketplace, it's kind of the Swiss Army knife. You actually have both of the technologies under one hood.
Yeah. So we basically have one test system that operates the same.
Oh, hey, our producer just stopped us. We got a comment.
I'm behind the camera today, so Sergio Razzo said slope is also the field equivalent of the cable manufacturer's strict standards criteria, which exceeds most field testing standards.
Yet another endorsement for the slope technique.
Absolutely.
Thank you, Sergio. Appreciate the input.
So, but like to kind of answer your comment or question. So at Megger, we've got kind of one test system, and it has different, I guess, voltage outputs to be able to help the person in the field, right? And so that's the TDM system. So we have the TDM 4540 and we have the TDM 6260. And the TDM 4540 is a 45 kV unit. It has 40 kV output for cosine rectangular. But with that unit, you can do VLF testing. You can do sinusoidal testing and cosine rectangular. You can do tan delta testing. And you can do partial discharge testing with all three different waveforms. So if you want to be able to have comparison, let's say you have old test data because you've done sinusoidal testing, but you want to move into doing cosine rectangular damped AC, you can still do that sinusoidal testing to have comparison with your old data, but then you can also take new measurements to be able to trend it and kind of compare it to how is it different. But it's been proven that cosine rectangular or damped AC, because of the correlation to power frequency, is just a more effective test for partial discharge. So those two test systems will be able to help you in the field to do field testing. The TDM 6260 is more tailored for higher voltage cables such as 25 kV or 35 kV systems.
Okay,
So,
and as I kind of mentioned, reading the IEEE literature and everything, it does make a statement that the PDIDs on acceptance testing of new prior to energization, whether we're doing it at the 0.1 hertz sinusoidal, the power frequency, the cosine rectangular, all the results should relatively correlate. But I do know, and just prior to the broadcast, we were just kind of going through our notes and everything. We were talking a little bit, and you brought up a really fascinating point, which helps also justify having a test set with both the cosine rectangular and the damped AC in it.
Sure.
You had mentioned that there is an advantage in using the cosine rectangular for acceptance-based testing on new cables and the common defects that would occur. And the damped AC would actually be the preferred, hold some advantages when dealing with the surface age cables.
Sure.
Can you elaborate a little bit on that?
So cosine rectangular waveform, it stresses insulation a little bit more than damped AC. And what I mean by that is your cosine rectangular is a continuous voltage wave, a voltage output that's supplied to the cable. So where you have this continuous voltage supply and you're ramping the voltage up to establishing your PDIV and your PDEV. But it's because of the stresslessness of the test, it's really recommended for acceptance testing because that cable's never been placed in service, right? Mm-hmm. So it's never experienced any of the electrical stress that a service age cable may have been subjected to, such as maybe it's overloaded or it's experienced a fault or it's experienced a voltage surge or any of these other things that can happen. Mm-hmm. And however, with damped AC, it's a little bit more of a controlled test because it's not a continuous output. It's a series of excitation shots. And that can be programmed by the user. Typically, we may start with 5 excitation shots per voltage step. So we would start out maybe at 0.5 or 0.7 U naught, so 0.5 or 0.7 times the rated voltage of the cable. And then you would ramp it up in steps until you identify your partial discharge inception voltage. And then after you identify that with damped AC, the advantage is the test result that you get after you identify PDIV, because it's a decaying waveform, which I kind of skipped over that. I apologize. But it's a decaying waveform where basically the first cycle of the wave is going to be the voltage that you requested whenever you perform the test. However, mm-hmm. each subsequent cycle that it goes through is going to be decaying, so the voltage will be a little less each time it goes through the cycle.
AC.
Yes, exactly. So, however, you can identify on the graph that you get on the test results where your PDEV is. So you don't have to run an additional test after you identify PDIV. You can identify PDEV with that test result. So basically that's very efficient and it's a time saver. However, whenever you use cosine rectangular, just because of the nature of the test results, mm-hmm. you have to identify PDIV and then you have to run additional tests.
Bring the voltage levels down.
So that you can identify PDEV. So, but just because the fact that the cable's never been energized for commissioning or acceptance testing, it's mm-hmm. recommended to use cosine rectangular because it's a little bit more stressful on the installation. But as we know, in mm-hmm. new cables, only the most gross defects are things that we're going to find. So that's necessary for that application.
And when you explain it in that manner and everything, it does make a lot of sense because I look at my own experiences going out there and using a lot of this product on the marketplace. Mm-hmm. I remember one situation where we were doing using one of the new insulated conductor committee terms, a monitored withstand. Yes. So I was basically using the VLF, mm-hmm. As the test voltage source. We were doing the withstand or dielectric withstand strength test on the cable. And this mm-hmm. was a new acceptance test. So it was a new cable being put into service, not had been energized prior.
Right.
And I've always been a little bit gun shy of a withstand test in general because mm-hmm. I got started in this quite early. I got started in this craft back around 1983, 1984. Mm-hmm. I've earned the gray.
I'm getting there.
And the problem I had, whether it was the old DC withstand tests, whether it was, because I was actually, my claim to fame was I was probably either one of the very first employees of the AVO International Company before it then became Megger.
Right.
Or I was the very last employee hired by the James G. Biddle Company of the era. And I worked in their cable and high voltage products group. Mm-hmm. So I remember we did power frequency AC systems, which were primarily sold to factories and research labs and so forth.
Sure.
And then at the time, the DC test sets were, the the field testing.
Mhm.
If you remember back to the old original IEEE 400
Mhm.
document where it only talked about DC.
Sure.
Okay.
Yeah.
But my problem with withstand testing, even back in those days and moving forward to current, was it is a time-based test.
It is. Yeah.
So whatever standard we were following at the time or whatever the so-called time periods were
Mhm.
that we were to test to, I always raised the question saying, okay, we ran a 30-minute test. Based on what I pulled as my data, what would have happened had I let the test voltage go one more minute?
Mm-hmm. Right.
And you always get the blank stare. Well, we really don't know what would have happened if you'd have gone one more minute.
Yeah.
So I always thought that, well, there's a bit of an Achilles heel to this technology, because what if I was growing a defect channel
Mm-hmm.
and I grew it 75% through the dielectric, ding, 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 the stopwatch goes off.
Yes.
Technically, I'm now putting it back into service in a weakened condition.
Mm-hmm.
So I love the concept of the monitored. And in the area of monitored, I mean, we can monitor partial discharge
Yes.
during the entire withstand test.
Mm-hmm.
And in this particular scenario on this acceptance testing, that's what we were doing.
Right.
And I believe it was about maybe 3 minutes into the test at, our top hold level voltage. I think we were running it over like 1.7 U-naught or something
Okay.
at the time. And it was about 3 minutes in, we started to pick up some activity starting. But again, the frequency, the amount of hits and everything were still relatively low.
Okay.
I think it was around maybe going into about 5 to 5.5 minutes. In our pattern, we started to see much more, and now we're now seeing it. And we did map it to a splice location.
Okay.
Upon going to the splice location, what we had found was the splice was mislanded.
Oh, wow. Okay.
So and for anybody that, what does that mean? It was a pre-molded splice. And when you had the conductor connector set, when you pull the splice body over, you want that to be dead center of the splice body, because there is a semiconductive area designed to go over that in order to, eliminate stress and so forth, create an equipotential zone for, and, obviously not, initiate electrical tracking. Well, when the individual was pulling the core material out of the splice to, kind of shrink down and get it on, the only thing I can observe is he must have pulled straight rather than curving.
Right.
So it's almost like a pair of Chinese handcuffs that locks up on you.
Yes.
The best thing to do at this point is cut the splice off, bite the bullet, pay for a new splice kit,
Right.
And redo it properly.
Mm-hmm.
They pulled in force, which shifted the whole body of the splice enclosure out of alignment. So in essence, what happened was the conductor connector was literally 50% outside of the semiconductor area.
Mm-hmm.
And after about 5.5 minutes, definitely we started to initiate partial discharge.
Mm-hmm.
Technique did very well. We found a defect, as part of the acceptance process. But that would have been very hard to find using the DAC technique, because, as you mentioned, these are momentary hits of short duration, where in this particular one, it was really more of a function of the amount of cycle counts and time that started to begin to trigger the partial discharge.
Mm-hmm. Well, I guess I feel like that DAC would still be effective on that. And so we mentioned earlier, with damped AC that you start at a lower voltage and you raise it up, and this is common to all partial discharge testing. However, with damped AC, you have that series of shots.
Right.
Well, you have an ability to increase the amount of excitations that you run. And with each excitation, you're going to increase the likelihood that you're going to find PD, because you're going to excite the electrons that are available in that area. And in your case, more than likely you had surface discharges that were occurring because of the misaligned splice, right? So if you had a case like that, then perhaps you would increase the number of excitation shots.
Instead
However,
of 5, maybe extend to 10 excitation shots.
but
Makes sense.
I would think there would be some kind of what's the word I'm looking for? Kind of indication whenever you run a different test, right? So if you were to run, let's just say a tan delta test, that may influence the insulation at that splice, right? So you might see some differences there. There's not going to be any moisture there, so it wouldn't influence it in that aspect, obviously. But the thing is, you said this was a new cable?
It was new, and partial discharge was not necessarily the mainstay of the testing that we were doing. Really, the client, it was the withstand test that they were looking for. So we were doing the full 1 hour and everything on it. But due to my distaste of timer-based test, it just so happened we had availability of the PD equipment and everything. And so it was like, let's do monitored. And I was actually, I think that was the point where, you know, in conversation, it just sounded logical that you would want to do a monitor because now you're no longer at the mercy of the timer.
Sure.
Whether it's the tan delta number starting to all of a sudden the stability starts to fluctuate and the tan delta number starts to grow, indicating that you initiated something, or seeing the PD events beginning. Obviously, we know immediately that we've triggered something. We can now at that point stop the test immediately, have dialogue with the client, or the timer is irrelevant at this point. You know, you either, you know, do your mapping with the PD or drive it to failure, get the fault locating equipment and make the repair, but you're no longer at the mercy of the timer.
Sure. Well, for that application, it would be better to use cosine rectangular. I mean, we spoke earlier about how it's more stressful, so those gross defects it would be more effective at finding on new cables. So also with cosine rectangular, whenever you run it, I said it was a continuous test. So it's similar to doing a VLF withstand test. Another benefit of that is that we have the feature in our equipment to be able to do the withstand test at the same time while you're doing the partial discharge measurement. So if you see any kind of weakness in the leakage current while you're doing the test, then you can just stop the test. You can be like, whoa, hold the phone. I think something's going on. And then you can investigate further. So there are other techniques. It's not just, I mean, I know a lot of people, whenever they think about VLF withstand, it's like, well, I just put voltage on and I hold it for an hour and there you go. It's no go, no
go or no go.
Excuse me, thank you. Go, no go. And that's all you have. Well, yes, with that test, the diagnostic information it's limited. However, there is some there, but there's also other techniques that you can use whenever you apply that for that certain application, where you can identify, wait a second, something's wrong, and you can stop the test and kind of reevaluate what's going on.
And again, you know, a lot of credit to you know, companies like Megger that, you know, manufacture and design and come out with the test and measurement equipment. I mean, it's just gotten absolutely wonderful out there where those options are right at your fingertips now because, you know, as we mentioned, you kind of have the Swiss Army knife. You know, I can run it in good old fashioned, just, you know, keep the voltage on there and run it for an hour and do the traditional go, no go withstand test, or I can activate, you know, and be taking tan delta measurements while I'm doing it, or I can activate and do the partial discharge. And then again, it was kind of funny. I go back to the days, you know, at Shermco, and you know, we would get clients that would call in and say, you know, well, I want you know, VLF withstand and everything. And even back in those days, you know, I would always be an advocate, you know, going to the salespeople and everything. So upsell them a little bit, you know, get them to do the monitored, you know, and the tan delta at a minimum and everything.
Right.
And like, oh, well, we don't want all that excess. I said, look, here's the reality. The test set that I'm going to be driving out there with that day has the tan delta feature built into it. So really what it comes down to, if the customer says, no, I don't want that data, I put my thumb over the reading. It's still happening.
yes, it's still there. Absolutely.
So, I mean, I credit you you test equipment designer, manufacturers and everything, because nowadays it's, it really comes down to why not do it?
Yes.
It's not taking me any more time in prep, setup. It's no more hardware than I'm going to be, I said, it's like, sorry, I'm a Sicilian boy, so I'm going to use a comparison of Prego spaghetti sauce. It's in there. All the goodies are in there.
Right.
You might as well take advantage of them. Well, a lot of what we've been kind of talking and focusing on does lend itself a lot to the medium voltage cables.
Mm-hmm.
And obviously a lot of the theme that we're seeing at PowerTest and in the NETA world, again, centers around these medium voltage.
Mm-hmm.
But rather exciting, and again, I'm going to take you back to the damped AC.
Mm-hmm.
I'm very impressed with this technique, and I don't have as much on time or experience with it as someone like yourself that has access to these devices and the designers and all the white papers that are coming out of Europe and everything on it.
Mm-hmm.
But one of the things I'm very impressed about is commissioning of transmission level high voltage cables.
Okay.
Can you talk a little bit about the DAC technique? And I mean, commercially available now, how high in voltage can we go?
Well, right now we have the DAC 300 system. So that's considered to be a portable system as far as, high voltage goes. And it can be set up in, a matter of minutes, and you can effectively do, partial discharge testing on transmission lines with that piece of equipment. And I mean, as far as the technique goes, I mean, it's pretty much identical to medium voltage cables. I mean, so there's not a lot of learning curve there. It's just the system is a little different just because of the fact that you have the higher voltages available. Yeah. So obviously the clearances are different and the equipment's a little different, but I mean, it's very comparable. And so that again, if you're already using one set of equipment, there's a lot of correlation from the DAC 300 to the medium voltage systems that we already have. So it's really easy to transition or to add that to your repertoire. So,
well, I know it is an area that the bulk of my conversations and inquiries that come into me, do tend to be more onto the medium voltage. That's the world I kind of played in, throughout my career. Mm-hmm. But I do get the occasional question that comes in, particularly from NETA test companies and so forth. They get an inquiry, hey, we got a 115, kV cable that, we're doing commissioning and everything on. The client would like something more than just, a withstand. And even there, once you start getting into like the 115 area, all right, we can still do VLF.
Sure.
But even there, the VLF test sets are getting kind of big and kind of heavy.
Yes.
Not as big and heavy in comparison to the 60 hertz test sets, but I mean, you are talking about some pretty substantial hardware that you're hauling around.
Absolutely, yeah.
And again, that was one of the areas that, when looking at the damped AC, and yes, I will say I had visited the Megger website. I watched some of the videos and everything that you had on it. Yes, there are more components and, everything that we're hooking up, but it almost seems like kind of an erector set that this breaks down, packs up into a relatively reasonable package that is transportable by what I would say normal service company vehicles.
Yeah, absolutely.
Yeah, we're not renting a special 18-wheeler to haul this. I mean, so it breaks down into small, convenient. And, I remember the video that I watched from your company and everything showing the assembly. And I was like, this is just absolutely brilliant. I was sitting back thinking, why can't I have a client call me up and ask for this so I can, get some on time and actually get to, do some practice and everything.
Right. Well, I mean, they're doing a lot of testing with that in Germany right now. And so there's going to be a lot more, I guess, coming out from the test results and things with that unit. I mean, obviously it's already being used in the field, and it, like you said, it breaks down, it goes into, 3 or 4 cases, and those cases are small and they're easy to transport as far as that equipment goes, and it can be loaded in a van or a truck. And in Europe, it's pretty much all vans. They're not big fans of pickup trucks. They're pretty much all vans over there. I went there back in September. I think I saw one pickup truck the whole time. So
you don't run across the pickup truck culture. Even I'll dare say, not just in Germany, but most of Europe. You don't see the pickup truck culture. And if you do see one, it normally is service work related, and it's not a beautiful, highly polished Denali going down the motorway with a gentleman in a suit and tie.
Right. Yeah. So, but yeah, I mean, the equipment is, I mean, not only for the high voltage equipment, but the medium voltage equipment, right? Because when you talk about 60 hertz systems, they're very large. So
yes,
you have logistical problems. I mean, if you have to go up to a set of stairs to an electrical room or a piece of a substation or something, then that creates more challenges. There's also safety concerns because you're at 60 hertz power frequency. So there's things that you have to be aware of whenever you're doing testing. I mean, there's safety concerns with all testing, but there's higher concerns whenever you're talking about 60 hertz. So the equipment that we're talking about is portable. You can take it into an electrical room. Not the high voltage units, but the medium voltage units. You can take that into an electrical room and set it up. You can, get it to where you need it to go. So logistically, it's not as big of a challenge. And then the high voltage equipment, the designers, the people that have engineered that equipment have made it as user-friendly from a setup and portability standpoint as they possibly can. I mean, there really isn't a way to make it, any better than what it is right now.
No, it's probably one of the best times to be in the field. And again, I credit a lot of, the user interfaces that you guys are designing and developing, the ergonomics of the equipment, how it comes together. I remember, good friend of both of ours, and hopefully you're watching and you don't mind me using your name on the podcast, but Scott Sinetti. I remember the first time that we had access to the Megger unit that had the cosine rectangular and the DAC technique in it. And we were at a local refinery in the Dallas, East Texas type area. I don't really necessarily, say the name of the company or everything for, privacy reasons and everything. But
Sure.
Megger was gracious enough to go ahead and give us a unit on evaluation. And with very little to no tutorial or anything. I mean, Scott and I, we had been doing partial discharge testing for longer than old men like to admit. But it was our first time using the Megger instrument. And I remember, Megger gave us a little bit of an overview and everything. And Scott and I, we don't need that. We can figure this out. We're smart guys,
Yeah.
And we fired up the software, and I will say the design, the user interface, that dial-based system that you have on your software where it like sequences you through the different, and it runs auto routines that,
Yes.
we never had. I mean, again, this is my my greatest kudos to any type of manufacturer. I always joke. I said, if I have to open up the user's manual, that's a design defect on your part. I never had to open up the user's manual. I mean, this thing was just so intuitive. But I mean, you had to have at least had a little bit of background though, like in partial discharge tests.
Sure.
You had a little bit of background of the concepts and what you were looking for.
Mhm.
But armed with that base level of training, it was so easy to get through. So again, major compliments to Megger and all of the manufacturers and designers these days. I mean, this equipment is just getting more flexible, easier and easier to use. My only critique and argument on it, and this comes from the trainer in me, because I remember like when I would do training at Shermco, great example would be winding resistance turns ratio testing on a transformer. I would only give the student a single channel hand crank, the old Biddle hand crank TTR.
Yeah.
When you can prove to me and show me that you know how to test a 3-phase transformer with a single phase hand crank,
Right.
then and only then will I allow you to use one of those beautiful automated 3-phase TTRs. But you had to first demonstrate to me that you knew how the measurement was actually being made.
Got to know the basics, right?
Got to know the basics. But that's my only critique on the brilliance of what you guys are bringing to the market these days. But it's getting to the point where it's like so easy to operate that you lose the base theory of what's really being done under the hood. And I do believe that is still helpful, because if I'm not getting the data that I think I should be getting, I'd like to know, is it something in the application? Is it something in the specimen? Is it something in the product that I'm using? So yeah, the old timer in me still likes a little bit of that manual, but I will say it is a pleasure using some of these new designs.
Sure. Megger's made a lot of strides to automate that equipment, to make it user friendly so that almost anyone in the field can use it. I mean, we're all about efficiency. We're all about usability. It's, I need to show up. I need to do my job. I need to do this as quickly as possible, because I don't need to be spending or wasting time in a user manual. And so the folks over in Germany, they spend a lot of time making the software better, and they're continually working at that. And the one thing that I can say about that is, whenever you have questions, about theory or application, Megger's got a lot of avenues that you can seek out to be able to learn those things. If that's what you're after. We have webinars that we do. We do them every month. We have testing tactics webinars. We have a YouTube channel. I mean, we spent a lot of time in the pandemic. Whenever we couldn't travel, we created a lot of how-to videos. They're short, 5-minute, easy to digest videos, and they'll tell you how to operate a TDM 4540. They'll tell you how to, if you have challenges with PowerDB and you don't know how to use a test form, it'll tell you how to do that. Or if you need to use a particular driver with your computer to be able to run, say, a Delta 4000 for transformer testing, we have videos on there for that. And I mean, there's just a lot of avenues. And then we also have our technical support group that I'm a part of, and you can call us, and we will do our best to answer your questions and help you out.
Well, that's very good for everybody to know. And definitely, the one thing I've always respected about Megger is your dedication to the education of the client, trying to make their life easy, trying to make sure that they are well educated, both before, during, and after the purchase, making sure that they're getting the most out of what they've taken ownership of.
Right.
Which is one of the reasons why we love bringing your product into our inventory from the rental, because we're well supported. I mean, if there is questions that we can't answer, we know we can always get you guys, and again, ultimately the client, has a wonderful experience. Now, I have noticed that behind us, the lamp went out, indicating that we are running at the end of our broadcast and everything.
It's been that long? Come on now.
it has been that long. Jason, thank you so much for taking the time out of your busy schedule to come over to our studios today and to talk with us. I am definitely excited to get down to Orlando and see you at the PowerTest conference. But hey, Matt is telling me we have another comment coming in.
We do. Will the cable panel be viewable on this channel?
That's a good question.
It'll be viewable on PowerTest TV.
Yes, I do believe that they will have PowerTest TV where you can get it. What I would probably recommend is go to the PowerTest website and go over the schedule and agenda. That will go ahead and let you know how you can get access to the cable panel. Obviously, if you're going to be down there in Orlando with us, just come on by that morning and that afternoon to our session track. Come on in the room, and it's going to be a good time. They've got some phenomenal individuals and brain trust on the panel. Why they put me in there must be for like comic relief or something, but they've really got some top-notch people on that panel. It's going to be a good time. But yes, the best access to it, I'd say go to the PowerTest page. But I do believe it will be on the PowerTest TV as well as in person. Again, Aaron or Jason, thank you. So yeah, get used to calling people by their last names.
Yeah.
But thank you so much for coming in today. I really look forward to seeing you down in Orlando. Absolutely expect to see my face pop in to your sessions. Please come into mine, and when you do, sit up at the front of the room. So if a question comes up that's too hard for me to answer, I have at least somebody in the room that knows what they're talking about.
I'll do the best I can.
All right. Thank you, sir.
Thanks, Tom. Appreciate it.
And we hope to see you at PowerTest 2023.